The European Space Agency's Jupiter probe is set to launch in just a couple of hours. The Icy Moons Explorer, dubbed JUICE, is the ESA's biggest planetary mission to date. It is designed to answer some tantalizing questions like, could the ice-encrusted oceans on one of Jupiter's moons be concealing extraterrestrial life?
The Jupiter Icy Moons Explorer, or JUICE, will be on its mission for around 7.5 years. Its destination is Jupiter, our solar system's largest planet. To get there, JUICE will need a lot of momentum. And that will mean several close flybys of both Venus and Earth. Researchers from the German Aerospace Center in Berlin will focus on Jupiter's 3 mysterious icy moons, which were discovered back in 1610 by Italian astronomer Galileo Galilei.
The biggest question of all is if they can support life, because they all have under ice ocean. In their interior, it's actually warm enough, for one or the other reasons, that they can have a water ocean.
Which is the most important prerequisite for the emergence of life. Europa, the smallest of the 3 moons, is believed to be the most likely candidate for extraterrestrial life. Beneath its icy crust lies an ocean, which could contain twice as much water as all of Earth's oceans put together. How thick is Europa's ice crust? How deep is its ocean? And what is it made of? That's what JUICE is setting out to discover. And it will explore Jupiter's other moons too, which may also boast several layers of water. To do this, the probe will repeatedly fly past them, making observations with the help of its 10 state-of-the-art scientific instruments. After 3 years, JUICE will enter the orbit of Jupiter's largest moon, Ganymede. It will be the first time a space probe has ever orbited the moon of another planet. An instrument co-developed in Berlin will use laser pulses to take measurements of Ganymede's surface. This will reveal whether Ganymede has an ocean of liquid water and locate any areas of interest.
With JUICE, we will explore conditions to see if life could have evolved, and also to find out where to look. Where on Jupiter's moons will we most likely find evidence of life? That will also be a task for subsequent missions.
JUICE will spend 4 years exploring Jupiter and its moons, uncovering as many of their secrets as possible.
And earlier I spoke with Mark McCaughrean from the European Space Agency. I asked him why the Jupiter Icy Moons Explorer, known as JUICE, is such an important mission.
Well, firstly, the thing that was in your piece there, of course, is that we believe that several of the big moons have water oceans beneath their surface. And that potentially presents the possibility that life might have developed there in places which are very different from the surface of the Earth or maybe the surface of Mars, deep under maybe tens or hundreds of kilometers of ice. These oceans are hundreds of kilometers thick, so much different to the water we have here on Earth. But the other thing which is important is we have to remember that we have this giant planet there as well, Jupiter, and the moons and Jupiter are all connected. It's the tides of Jupiter which are actually keeping those liquid oceans in that liquid state. And we know that there are many thousands of planets orbiting around other stars in our Milky Way galaxy and beyond. And so in a way, by studying this gas giant planet and its moons in detail, we also will be able to bring information to help our understanding of planets elsewhere in the universe.
And how about your understanding of sustaining human life? Hope for that.
Well, one of the big problems we have to face as a spacecraft, actually, going to Jupiter, is that Jupiter has this enormous magnetic field, much more powerful than the Earth's, and that channels particles from the sun, which create a very dangerous radiation environment. So that's actually the reason that our spacecraft is going to go into orbit around Ganymede, which is a bit further out than Europa. Europa's further in, closer to Jupiter, a much more dangerous environment. So humans going to this Jupiter environment and finding a place to live is probably fairly unlikely. But of course, deep under the ice, they're very protected down there. So if there was potentially in the past or even today some kind of microbe that lives under there, they at least would be protected from that radiation.
How can our viewers keep track of your mission? How can they follow you?
Well, the first thing is that the launch is this afternoon at 2:15 here German time. So we'll be going up into space then from French Guiana, and we have an 8-year journey ahead of us, which is interesting. We have to fly past the Earth again 3 more times in order to use the gravity of the Earth, once past Venus, and so we only arrive at Jupiter in 2031. But we will have an enormous amount of material which people can read today online and follow the launch itself. And over the coming days, we'll be opening up the solar panels and then opening up the various antennas on board. So it's a pretty exciting phase now, but in a way it's just the middle of the mission. We've been building it for more than 10 years. Today's the launch, and then the science all comes all the way out there in 2031 to 2034 when we go into orbit around Ganymede.
So your first results you're expecting as of 2031?
Well, from the Jupiter environment, of course. One of the things which is interesting is that we could get there quicker, but we wouldn't be able to stop and go into orbit. So we have to take this very circuitous route, kind of just getting up enough speed to get there, but not so much that we can't stop when we get there. We will be taking pictures at Earth and Venus on the way, but not really for science. So first science, 2031, yes.
Okay, Mark McCorgrin, really fascinating stuff. We look forward to following you. We wish you all the best. Joining us from the European Space Agency. We appreciate it.
Thank you.